Well, in the access network today, we see quite a number of challenges. It's a mixture of various challenges. We do see, of course, a growth of bandwidth of the services, etc. But on the other hand, we don't see a massive rollout of fiber-based access. Then on the other hand, we also see or know that what some operators are deploying today, and that is TDMA-based optical access, will not scale in the long term if bandwidth really is further increasing. Nationwide optical access seems to have some difficulties in Europe, because it is there in Japan, it is there in South Korea, and it is at least there in parts of the US and at least some big cities in China, maybe even in Moscow, elsewhere. But there is no mass rollout of optical access in Europe, and that is mainly due to cost. That is, of course, one of the main problems, because the cost associated with nationwide optical access is huge. We are talking multiples and potentially multiples tens of billions of euro per country. One of the problems and challenges for optical access is not because there isn't any killer application. The killer app, of course, is ultra high resolution 3D video. And today we see the problem that this application isn't there on a broad scale because the networks aren't there. And on the other hand, the networks aren't there yet because the users are not requiring massive bandwidth, and they aren't requiring massive bandwidth because they don't have this application, the ultra high resolution video. So it's sort of a chicken egg problem. There's a mixture of approaches towards next generation optical access. It's really a mixture. First, there is a massively fragmented approach, meaning that we will not see one homogeneous solution nationwide, provided by one operator or service provider. I guess we won't see this in Europe, and that is unlike things are happening in Japan or South Korea. So we will see little city carriers and utilities and all these sorts of operators. We will see lots of cooperations and new types of cooperations. The keyword here, of course, is open access. It means that operators, and in particular that includes the incumbents, will deploy only in large cities where they know they can make some money. And we will also see a paradigm shift. In the past, we saw deployments first, and then the operators and service providers trying to get their customers. This will change. The new model will be sell first, buy or build then. And that's really the problem, because in effect, due to the cost that the optical access will show, it's only the large city areas where operators can make some money. And if bandwidth grows much the way it did the last 20, or even if you like the last 100 years, we must expect incredible bit rates, say in 10, 15, 20 years from now, at least in the range of several hundreds of megabits per second per client. And if you combine this with the respective services and applications who will drive this, and that again is high resolution video content, then it is pretty likely that the technical solution to deliver these services is streaming rather than burst mode transmission. If the video services become that broadband than we expect today, i.e. that a single stream or say service can easily fill 100 or 120 megabit per second, then burst mode transmission runs into sort of a dead end. First, there is standardization. What we do see in standardization today heavily points towards TDM or TDMA-based solutions. We do see only little approaches towards WDM-PON standardization. Then there is, of course, cost. That is the old counter-argument to WDM-PON. It's what originally led to the approach of seeded reflective WDM-PONs because the respective components were cheaper. And then there is, of course, some technical or technology hurdles to take, and these mainly relate to photonic integration. I mean, in a WDM-PON, in the OLT, in the site that is accommodated in the central office, we need a multi-channel transceiver array that is packed as densely as possible for all good reasons, for reducing cost, for reducing footprint, for reducing energy consumption or power consumption, in effect for reducing everything, to reduce cabling effort, etc. And today we don't have these highly densely packed multi-channel transceiver arrays. It's something that is investigated in academia and some of the components vendors. But we don't expect these respective components to be available over the next, say, 18, 24 months or so. So clearly there is some things to be done in the technical area, and then on the other hand, WDM-PON has to be supported by standardization. And if both work hand in hand, then one really can expect that the key components get into price domains where the respective WDM-PON systems solution are very attractive. We have WDM-PONs that are based on seeded reflective components. That is, the ONUs, the client equipment, is seeded with wavelengths coming from the OLT, from the central office. And the respective wavelengths are reflected and overmodulated. That's how it works. So we have, of course, alternative transmitter technologies, and that is tunable lasers. And even in the camp of tunable laser-based WDM-PONs, we have to see the split between coherently detected WDM-PONs, and because they are coherently detected, they can also be ultra-densely spaced in the wavelength domain. And then we have the directly detected WDM-PONs, which are based on tunable lasers. And since they are using direct detection, they are inherently much simpler. They are consequently cheaper, even over time. And since, again, they are simpler, they also can lead to reduced power consumption, which is very relevant in access because of the sheer numbers of to be deployed lines. We really believe that the midterm winner will be the WDM-PON, which is based on tunable lasers on the one hand side, and also based on direct detection in the receivers on the other hand. And that's because it does provide all the performance that we need, including some scalability for future bandwidth growth, including the reach requirements that we see for the next generation optical access networks, with reach potentially exceeding 20 or maybe even 40 kilometers. But it's sufficient for these requirements. It doesn't need the coherent detection, which would make it more expensive, which would increase the power consumption. By the way, it is exactly this technology that we are now seeing in backhaul and metro applications for almost a decade.